In the name of God, hello dear students, welcome back to Thinkable Physics. This is my YouTube channel. My name is Masood, I'm a physics teacher. In this lesson, I want to explain one more phenomenon that is taking place in capacitors and in some natural phenomena like lightning. The process is called discharging or electrical breakdown. Before I explain the discharging or electrical breakdown, I want to remind you about the previous lessons. Actually, in previous lessons, we talked about charging of capacitor, if you remember. Charging of capacitor means transferring of electrons from one plate of the capacitor to the other, and eventually each plate carries an opposite and equal charge. This is called charging. But right now in this lesson, we have the opposite process of charging, which is called discharging or electrical breakdown. I want you to be with me to get information about this process. Let's get started. Let me read the title for you. Discharging a capacitor releases its charge. This is our title. I included 3 definitions for discharging or electrical breakdown in my pamphlet. I want you to be very accurate, to read them one by one. Right, the first one, releasing charges from high potential energy to low potential energy. This is the first definition. Think about a lightning thunderstorm, for example. Think about this thunderstorm. Actually, thunderstorm consists of 2 parts: thunder and lightning. Thunder is the roaring of the sky. Leave the roaring or leave the thunder. Our concentration is on lightning, right? So, how is lightning actually happen? Lightning means actually releasing of electrons or flowing of electrons and protons is not just for electron actually. Let's say releasing free charges, positive, isolated positive charge, isolated negative charge, right? From high potential energy from the cloud to the ground. High potential energy, I mean cloud. Low potential energy, I mean ground. So when the lightning directed toward the earth from the sky, this is called actually electrical breakdown or discharging. By the way, why do we say high transferring charges from high potential to the low potential energy? Let me actually tell you numerically. It's not in our textbook, but actually it helps us to understand this phenomenon better, right? For example, think about the voltage or electrical potential for the lightning within the clouds. So delta V within the clouds is equal to 300 megavolts. It means 300 million volts. It's a very extremely actually high voltage. So we have a high voltage, extremely high voltage within the cloud, right? That's why we say releasing charges from high potential energy to the low potential energy. So what's the potential energy? What's the potential difference of the Earth? Potential energy of the Earth is 0. So transferring charges from these actually huge numbers, 300 million volts to the 0 volts. That's why this is about the first definition, transferring charges from high potential energy from the cloud to the low potential energy to the ground. And you know that the potential energy of the ground is 0. Voltage of Earth is 0, right? It's considered actually 0 level for measuring the potential differences. And by the way, our planet Earth can accept actually these energies without changing its potential energy. It's very weird, right? Earth accepts these actually high voltages And actually, this voltage, let me tell you one more information. Actually, these voltages produce 13,000 amperes. So the current, these high voltages produce a very high current, 13,000 amperes, actually enter the earth in a split second. And earth accepts these currents, earth accepts these high voltages without changing its voltage. That's why earth is considered a reference point for measuring potential difference. That's why earth is considered a giant capacitor, right? Earth accepts, I say earth collects or accepts charges. So this is the function of capacitor. That's why earth is considered a giant capacitor. That's the first definition. The second definition, it says a state of lowest potential energy. It means the object, the capacitor, the cloud, battery, whatever device actually loses its energy. Doesn't it does actually doesn't the cloud lose its energy? Yes, it loses its energy, right? So it loses energy, 300 megavolt, turns to the zero in a split second. That's why it's a state of low potential energy, means the object loses its energy. The third one, flowing charges from a capacitor or battery or etc. in a very short time interval. I want to tell you a note, and it's very important. I want to highlight important, actually, expression here in this definition. Guess which the expression is important here, right? Flowing charges, it's very important. What's the mean flowing charges? It's very important for grade 12, right? Flowing charges means producing current. This is the definition of actually current. You see, I told you, actually, when the lightning is taking place, infinite number of proton, infinite number of electron, individual proton, actually directed toward the earth. That's why, in other words, we say 13,000 amperes. So where does this number come from? Why do we actually express it as amperes? Because flowing charges simply means actually producing current. Let me write it for you. So flowing charge means producing current. For flowing charges from a capacitor or battery in a very short time interval. Right. Let's move on to the some tips here. I want you to be with me to get information about, to understand these tips. The first step: discharging happens faster in a capacitor than in a battery. Discharging happens faster. Let me highlight it for you. Discharging happens faster. Happens faster in what? Happens faster in actually capacitor, right? In capacitor than in a battery. Let me give you an example. For example, think about the flash of camera. Whenever you hit the shutter button of the camera, actually the press of charging, the actually flash of camera discharges in a split second, in 1 second. It doesn't take time, right? But what this is the discharging of what? Discharging of capacitor. Think about the discharging of the battery of your cell phone, right? And I want you to actually not to charge your cell phone for a day. If if the battery of your cell phone is in a good condition, right? If the battery is new, maybe the process of discharging actually takes 2 days, right? Takes 2 days. That's why the process of discharging in battery happens very slowly compared to the what? Compared to the capacitor, right? This is about the first tip. The second tip, through discharging, charges move back from one plate of the capacitor to the other. And I explained it for in the introduction. I said that the discharging is the opposite process of the charging, right? During charging, actually, charges have a particular direction, right? But in discharging, actually, charges move back. Charges retreat to the original position. That's why they get the opposite directions. Number three, flow of charge is equivalent to produce a current. I included actually this note here. Flowing of charge, it's very important. Flow of charge is equivalent to electric current, producing electric current. I want you to memorize it as your names. It's very important, especially for grade 12. So we have one more information. It says lightning bolts produced when air particles undergo electrical breakdown to form plasma state, free isolated charges, as shown in the figure. So lightning actually is due to the what? Lightning is due to the actually is due to the collapsing of particles of air. What do I mean by collapsing of particles of air? Because air is in actually gas state, right? Air is in a gas state. When electrical breakdown is taking place, or when air particles are exposed to the what? When they are exposed to the electrical breakdown, they collapse. No electron actually is bound to the nucleus anymore. Under these actually high voltages, under these actually harsh conditions, let's say, temperature of the clouds, temperature of the air rises actually to the thousands of Celsius. That's why gases automatically turns to the what? Turns to the plasma. How do they turn to the plasma? The electron actually escapes from the attraction of proton, right? They are no longer bound to one another. Electron becomes free individual charge. Proton or nucleus becomes free proton charge. And this is the plasma state, right? So lightning is in plasma state, and it's due to the what? It's due to the electrical breakdown within the clouds. And that's actually all for the lightning. I'm going to show you some questions have to do with the lightning, right? We have some. I included some questions related to this process, related to the electrical breakdown or discharging. I want you to read them and circle the correct answer and comment them for me after you watch the video. Question number one, question number two, number three. I explained them in advance. I'm not gonna answer them. I wanted to go over the answers and actually comment them for me. So we have how many questions? 6 questions, right? I included 6 questions. And at last, we have a tip. Charging and discharging are opposite phenomena. That's all for today, guys. Thank you very much for watching this video, and bye-bye.